Algebra 2 students. Today we're going to start looking at quadratic functions. We're going to look at two forms of the equation. We're going to look at how do we graph these, how do we find the different parts, like the vertex, axis of symmetry, and that kind of thing. Let me get Doceri going here so I can write with the iPad. There we go. All right, so the next unit we're going to study is quadratic functions. From between now and Christmas break, we're going to look at, the graphs, the parts of the graph, vertex, axis of symmetry, y-intercept, x-intercept, those kind of things, and transformations. And we're going to analyze the graphs of quadratic functions. After the break, when we come back in January, we're going to look at how to solve quadratic equations by 4 different methods. So right now we're looking at graphs. So you take a look at your handout that says characteristics of quadratic functions. There are 2 forms. Quadratic always has an x squared, okay? But there are 2 forms. There's a vertex form that has the a, the h, and the k. We've looked at a, h, and k with absolute value, okay? And I don't know if you remember that we said that the vertex was hk, okay? But if your equation is in vertex form, the vertex is told by the 2 letters h and k. Or you might be in general form or standard form, where you have the ax squared plus bx plus c. You can have it's the same equation, just 2 different forms. Okay? All right, this is in this equation, a, b, c, and h. A, b, and c, h, and k represent constants, but a cannot equal 0. Why is it that a can't be 0? Think if we had 0 times whatever this is. Quadratic means it has an x squared term. If I multiply this squared by 0, there's no longer an x squared term. Okay, in standard form, if I have 0x squared plus bx plus c, I no longer have an x squared term, so I don't have a quadratic. So whether you're looking at vertex form or standard form, the a cannot be 0. Okay, this table is going to be really helpful for you. It tells you how to find the different parts or characteristics of a quadratic function from the vertex. You can find the vertex, you can find the axis of symmetry, the y-intercept, the point symmetric to the y-intercept. Let's take a look for a minute at a quadratic function. Let me get this to. Okay, so anytime you have x squared, you have a parabola. This parent function, the vertex is at 0, 0. Okay, the axis of our, vertex is here. Okay, in this case it's 0, 0, and I just misspelled vertex. Let's fix that. Axis of symmetry. When we did absolute value, we had an axis of symmetry that went down the middle. Same thing for quadratics. These parabolas have an axis of symmetry, which is a line that divides that parabola into 2 equal parts. What else do we have? A y-intercept. That's where it crosses the y-axis. The x-intercept is where it crosses the x-axis. And we've got a point symmetric to the y-intercept. Let me erase that part. Okay, so let's say, let me erase this one. If I have a parabola here, like this. Okay, and we would have our axis of symmetry is going to go right down the middle. A little y-intercept. And the point symmetric is like the mirror image across that axis of symmetry. That's the point symmetric. And we're going to learn how to find that from both forms. Okay. So this little chart that's on your paper is very handy. It tells you, you can see it gives you the standard form and the vertex form. It tells you where the A is, where the H is, where the K is. Excuse me, where the A is, the B and C. So when you have vertex form, just like we did with absolute value, this is vertex form. That is not the color that I want. Let's see. This is vertex form, has the A, the H, and the K. The vertex is HK. Axis of symmetry is X equals H. To find the y-intercept, you would plug in 0 for X. You can do this with any kind of equation. If you want to know what the y-intercept is, plug a 0 in for the X, and you can find the y-intercept. Okay. If your equation's in standard form, and we're going to do some examples of this in a minute, to find the vertex, you would find out what your A, B, and C are. You're going to do this negative B over 2A. Now, we know this vertex has an X coordinate and a Y coordinate, right? So the X part of it's going to be negative B over 2A. Then we're going to plug that into the equation to find the Y. Axis of symmetry is this negative B over 2A. The y-intercept, most of you remember that you can tell that from here if it's in standard form. Okay, points symmetric to the y-intercept. The y-intercept and other points can be reflected across the axis of symmetry. So we'll look at that. It's mirror image. And x-intercept, you can find those from a graph or a table. X-intercept where the y is 0. Or you can use your TI Inspire, you can use Desmos. Okay. Over to the side of your paper, notice it says that the two forms of quadratic equations provide information about the function's graph in different ways. Some things are the same regardless of which form you use, and you can tell that from this chart. Okay, let's keep going. This says, find each characteristic for the functions described. Okay, I still want to get that over in the middle. There we go. Let's look at vertex form first. In this case, remember we have A times X minus H squared plus K. So in this case, what is the A? There's no number in front of the parentheses, so A is 1. This is X minus H, so just like with absolute value, we change the sign. H is 1, K is negative 4. Remember, if you look right above at the chart, it says that the vertex is HK. So our vertex is going to be 1, negative 4. The axis, that's why they call it vertex form, because it's really easy to find the vertex when it's in that form. The axis of symmetry is going to be X equals H. What's our H? Our H is 1. The y-intercept, if I look back at my chart, it says plug X equals 0 into the equation. So take this original equation, and we have y equals 0 minus 1 squared minus 4. I replace the X with a 0. 0 minus 1 is 1, negative 1, minus 4. Negative 1 squared is 1. 1 minus 4 is negative 3. So we'd write that y-intercept as 0, negative 3. It's an ordered pair. What did we do to find the y-intercept? We plugged in X for the, we plugged in 0 for the X. The point symmetric to the y-intercept. To do that, we would look at the graph. So let's do this a second. Okay, so what do we know about this parabola? We know that the vertex is 1, negative 4. My line's a little crooked. Okay, so the vertex is 1, negative 4. We'll talk about later that this A is positive, so it opens up. The axis of symmetry is X equals 1. Change colors here. So here's your axis of symmetry. That means your parabola is going to be symmetric around there. The y-intercept is 0, -3. If my line was straight, okay. Now, let's talk about what are we looking for next? Is the point symmetric to the y-intercept? Symmetric means mirror image. This is the y-intercept. It's 1 unit away from that. So we go 1 unit this way, and that's your point symmetric to the y-intercept. It's a mirror image across that dotted line. And that point is 2, 1, 2, -3. Then we need the x-intercepts. It says we can get these from the graph or a calculator. Okay. So let's do this. Let's look at Desmos. Let's graph this equation. This equation in vertex form was y equals x minus 1 squared, whoops, not 2, minus 4. Okay, so what did we learn a while ago? When we did HK, we said that the vertex was 1, -4. There's that. The y-intercept is 0, -3. The point symmetric to the y-intercept is, click on that point, and you have 2, -3, if I can get it exact. There we go, almost. There we go. There's the point symmetric to the y-intercept is 2, -3. What are we looking for? X-intercepts. X-intercept is where it crosses the x-axis. There's one at -1, 0, and one at 3, 0. See how easy it is to tell that from once you type it in the calculator? You can also go over here to this gear and look at the table. What do you notice? Where x is -1, that's an x-intercept, right? Here's x-intercept at -1. What do you notice in the table? The y is 0. What's our other one? 3. So what if I type a 3 here? And you know the y is 0. What was the y-intercept was 0, -3, right? I want you to notice something. The only part of this students sometimes have trouble with is that point symmetric to the y-intercept. Look, here is our y-intercept. Right here. If I have a point symmetric to that, it's going to have the same y value. Where's your point that has the same y value? It's 2, -3. So we can find these from the equation. We can also use the calculator to find all of this. All right, so what were our x-intercepts? -1 and -3. Okay, let's go back to your paper. That's the key. Okay, so for this vertex form, we had the vertex of -1, 4, and I'm sorry, I got that backwards. It's 1, -4. And we got that from our H and our K. And then the axis of symmetry was x equals 1. That's always going to be x equals whatever your H is. And then we got the y-intercept is 0, -3. We looked at the graph and found the point symmetric was 2, -3. That's easy to find from the graph or the table. X-intercepts again from the graph or the table, -1, 0, and 3, 0. Okay? Now, let's look at this one on the right. I'm sorry, on the left. I can't even talk today. The one on the left, it says y equals x squared minus 2x minus 3. This is standard form or general form. That is, if you look back up at your chart on the top, ax squared plus bx plus c. So for this one, a is what? A is 1. That's the coefficient of your x squared term. B is -2. And C is -3. Okay, be sure you watch your signs with that. Now, what does your chart say for the vertex? It says -b over 2a So b is negative 2, negative b over 2a. What happens to that minus minus? So that's 2 over 2. What's 2 over 2? That's 1. Now, what does it say? To find our vertex, remember we have to have an x-coordinate and a y-coordinate. So how do we find that? Look at your chart. It says find negative b over 2a and then plug that into the equation to find y. So I'm going to take this equation right here and go 1 squared minus 2 times 1 minus 3. 1 squared is 1. That's negative 2. 1 minus 2 is negative. Did I do that right? Hold on. Time out. X is 1. 1 squared is 1. That's minus 2. One minus 2 is negative 1. Yeah, that's right. 1 minus 2 is negative 1. Negative 1 minus 3 is negative 4. You're catching me here. It's like 5:25 in the afternoon. I've taught all day. I'm kind of tired. So what did we do? Take this. How did we find this 1? That's negative b over 2a. Then we take that 1 and plug it in for these x's and get negative 4. Axis of symmetry, if you look at your chart, it says x equals negative b over 2a. We already found negative b over 2a, and it was 1. So that axis of symmetry is going to be x equals 1. The y-intercept, that's from your equation. Look at your chart up above. It says 0c. What's our c? Our c is negative 3. Are you noticing anything about these two equations? The vertex is the same. The axis of symmetry is the same. The y-intercept is the same. Guess what? The point symmetric to the y-intercept is the same, and the x-intercepts are the same. Okay. How do you find the different characteristics of a quadratic function from the two different forms of the equation? You either use the a, the h, and the k, or use the a, b, and c to find these parts. Now, let's go back to Desmos a second. And here we graphed that equation in vertex form, x minus 1 squared minus 4. Let's graph it in standard form with x squared minus 2x minus 3. What do you notice? It's the same exact graph. What's the vertex? There's the vertex, negative 1, 1, negative 4. The axis of symmetry always goes through the vertex. Axis means line, symmetry means mirror image, and it always goes through your vertex. So the axis of symmetry, x equals 1. Remember, vertical line, x equals. What else do we need to know? The y-intercept. Nope, that's not the y-intercept. This is the y-intercept. And the point symmetric to the y-intercept. Looks like a snake or a mouse. All right. Then the x-intercepts here. So what do we know about these two equations? They made the same graph. These really are the same equation. This one, the one on the left, is in standard form or general form. The one on the right is in vertex form. Okay. All right. I'm going to break this up into two videos because that's pretty long. So let's stop that one.